All right, everybody, welcome to the Pre-algebra 12.3 video. We're talking about angles and polygons. So before we get into that, let's talk about the angle measures inside convex polygons, okay? So if I gave you that shape, you would probably say, hey, it's a triangle, right? You'd be right, of course. And if I said, what is the sum of all the angles inside that triangle, or inside a triangle that looks like that, or inside of a triangle that looks like that, said, what's the sum of all the angle measures inside of each one of those triangles? You would say 180 degrees, right? All those angles added up must equal 180, 180, 180. Okay, so how about a square or a rectangle? Okay, well, we know that rectangles contain 4 right angles, and we know that right angles are 90 degrees, right? So we have 4 90-degree angles, so that's going to equal 360 degrees. But also, the same thing goes with a parallelogram, okay? Some angle, some angle, some angle, some angle. All those added up are going to be 360 degrees as well. So how do we know that there's 180 degrees here, but 360 degrees inside of there? Well, I'm going to show you. So I'm going to draw a convex polygon, okay? Convex polygon. All right, pretend that's a straight line. All right, so what have I just drawn? Okay, a pentagon. Now, is it a regular pentagon? Doesn't really look like it because it looks like this side is much longer than this side. This side is definitely longer than these 3 sides. So it's not a regular pentagon, but it is a pentagon because it has 5 sides, and it's convex. Okay, meaning if I were to, draw, a line from any 2 points inside this figure, those 2 points connected would never run outside of the figure, right? Such as that point and that point. If I draw them like that, of course, that little line I just drew would never run outside. Okay, and there are no 2 points you could connect with a line that would run outside. So now what we're going to do is we are going to start from one vertex. We're going to pick a vertex, and I'm going to pick that one right there. And from that vertex, I'm going to create triangles by drawing a line to the other vertexes. So I'm going to draw a line to there, then I'm going to draw a line right to there. Okay, so now let's think. Well, could I draw a line from here to here? I could, but it wouldn't create a triangle. Could I draw a line from there to there? Yeah, I could, but again, wouldn't create a triangle. All right, so how many triangles do I have here? Well, now I have 1, 2, 3. All right, so now that we have 3 triangles, we're going to multiply that by the measure of the interior angles of a triangle, right? So we know that this triangle here has 180 degrees inside of it. This triangle here has 180 degrees inside of it, right there, right there, right there, and then there, there, there. And then this triangle also has 180 degrees inside of it. So we have 3 180-degree triangles. And if we multiply that, what we end up getting is 540 degrees, okay? So what is 540 degrees? Well, that's the sum of that angle, that angle, that angle, that angle, and that angle of the pentagon, okay? So why don't you take a second. I want you to draw a 7-sided figure, and then I want you to figure out how many triangles are in it and then how many angles it has. All right, so here's my 7-sided figure. You may have drawn something that looked a little different. That's totally okay. So let's figure out what the total measure of all the interior angles are. So I'm going to start from that vertex. You could pick a different one if you want. And I'm going to draw to there, to there, to there, to there, and that's it, right? If I draw a line from here to here, it doesn't create another triangle. So I have 1, 2, 3, 4, 5 triangles. So what's the sum of all the measures? Well, we're going to take 5 times 180 degrees to find that. And 5 times 180 degrees gets you 900 degrees. Okay, so again, what does that mean? Well, it means if we go back to our original shape, so we pretend all the triangles don't exist, that angle plus 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 that angle all equal or total 900 degrees. So like in this figure, what are we finding? Well, again, we're finding interior angles because these angles are inside the polygon, okay? So there's another way to find the measures inside a polygon, okay? So this would be item number 2. And the other way is, so we have splitting up triangles, we're talking about a new way now. If you take n minus 2 times 180, we will figure out the sum of all the interior angles. Now you might be asking, well, what is n? Well, n is going to be the number of sides. So, for example, with this seven-sided figure right here, so we have a heptagon, okay, so it's 7 sides. So we're going to take 7 minus 2, and then we're going to take that times 180. Okay, well, 7 minus 2 is 5, and we know that 5 times 180 from over here also equals 900 degrees, right? Okay, so either way you want to do it, if you want to use the triangle method or the formula method, I don't really care, okay, either way. But there's one thing that the formula helps us out with too, and it's this. All right, so this formula can also be changed just a little bit and used to find the measure of each individual angle inside of a regular convex polygon. So what is a regular polygon? Well, remember it's a polygon where all the sides are exactly the same, right? So a square is a regular polygon, right? Because that side is equal to that side is equal to that side is equal to that side. So let's use that same formula we had before, which was n minus 2 times 180, okay? But this time, we're trying to find the measure of each individual angle, not the sum total, each individual. So what we're going to do is we're going to divide this thing by n. So again, what does n stand for? Well, n stands for the number of sides. So in the square here, we have 4 sides. So we're going to subtract that from 2 times 180, but we're going to divide that by 4 again. Okay, the n there is the same n that's up there. All right, so that's kind of simplified this expression. 4 minus 2 would get you 2 times 180 divided by 4. Well, let's see. 2 times 180 is 360 divided by 4, and 360 divided by 4 is 90 degrees. So what is 90 degrees? That's the measure of every single angle inside of a square. And we know that to be true. Okay, square is kind of easy because a square we know has 4 right angles, which are also 90-degree angles. But does that work for another shape? Why don't you try this one? Okay, I want you to draw this shape. Okay, we'll do a regular octagon. Okay, so it's not quite exact, but we're going to say all those sides are the exact same length, okay? And I want you to figure out what's the measure of each individual angle in there and use our new formula. So pause the video, try that, play it when you're done. All right, so I forgot that side is also the same. So our formula for each individual angle was, again, n, which stands for the number of sides, minus 2 times 180, but we're going to divide that by n. Okay, so we have 8 sides to an octagon, so subtract 2 times 180 divided by 8, okay? So let's see, that's like saying 6 times 180 divided by 8. Well, let's see, 6 times 180 is going to get you 1,080, divide that by 8, and 1,080 divided by 8 gets you 135 degrees. Okay, 135 degrees. So what is that? That is the measure of every single angle in that octagon. Now we can check it using the triangle method. So I'm going to start that vertex and go to there, 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 and I'm done. So I've created 1, 2, 3, 4, 5, 6 triangles. Okay, and let's see, 6 times 180 gets you 1,080. Now you might be saying, wait, but 1,080 is different than 135. Well, you'd be correct, but what we're saying is that 1,080 is the measure of all of these angles added up. Okay, so if we took 135 degrees and multiplied by that by the, well, let's see, 1, 2, 3, 4, 5, 6, 7, 8 angles that we have in that in that octagon. Well, that would get us 40. Okay, so then 24, so 28, and 10. Look at that. Okay, so triangle method, formula method, either way works just as fine. All right, so next, let's talk about exterior angles. And they're just angles that are formed by extending the side of a polygon. For example, so here we have a triangle, right? Okay, but we've extended the sides of some of the polygons, and sorry, that should be more straight. Oh yeah, that helped. Anyway, So exterior angles. What are our exterior angles here? Well, that would be one right there, and there's another. Okay, so when you extend the sides, you form exterior angles. Okay, now they are adjacent to some interior angles, such as those right there. Now the key thing though is an exterior angle, okay, with its adjacent interior angle, they form a straight line, otherwise known as 180 degrees. So if I know that this right here is a 95 degree angle, and I want to know what's the measure of angle 1, okay, that angle right there. Well, I know that together they form 180 degrees. So I could take 180, subtract from it 95, and get my answer. So that'd be like 5, 17 and 9, so that would be 8. 85 degrees, right? 85 degrees would be the measure of that angle right there. And you know, here, if you knew, let's say you know that this angle right there is 30 degrees. Well, what would that angle right there be? Well, hopefully you could probably just do it in your head and say that, well, the measure of angle 2 there is actually going to be 180 minus 30, which would get you 150 degrees. All right, so we're going to put it all together, okay? So we're going to say that you work on the product development team at a company that makes weights, okay? And you're tasked with developing weights that save some space. So they give you one of these weights, and at the side, it's a regular hexagon. It's not quite exact, but we're going to pretend it's a regular hexagon, okay? And what you need to find is, when you set this weight down, what's the angle that's created right there, okay? But also, in order to know that, we might have to know something else. Well, we'll have to know what that angle is right there as well. So we're going to call it angle 1, and we'll call this one angle 2. So we're going to find the measures of angles 1 and 2. So how do we do that? Well, remember, this is a regular hexagon, and we have a formula for finding the angles, the interior angles of regular shapes, right? And let's see, what was that? Well, remember, it's this one right here, n minus 2 times 180 times n. Now, what does n stand for? Remember, n is the number of sides, right? So let's see, number of sides, there's a 6-sided figure. Oh, and I forgot the parentheses. Make sure you put the parentheses around there. Super important. So, n minus 2 would then become 6 minus 2 times 180, and then we'll take that divided by n again, which we said was 6. So, let's simplify. 6 minus 2 would be 4 times 180 divided by 6. Okay. Well, 4 times 180 would give you 720. Divided that by 6, and if you take 720 and you divide it by 6, what do you get? Well, you get 120 degrees. So what's 120 degrees? Well, it's every single angle inside here, okay? So all of those are 120 degrees. So we just found the measure of angle 1, okay? That would be 120 degrees. So we're done with that part, but we still need to find angle 2. Well, remember, this line here that's been created, okay, that creates this angle, is a continuation of this line. So angles 1 and 2 together should be 180 degrees. So if angle 1 is 180, then what's angle 2? Well, that must mean angle 2 has to be 60. Okay, that right there must be 60 because those two together make 180. And you would be done. That's all I have for you guys on this video. Thanks for sticking with it. Look forward to seeing you guys later.